Hi folks, we're going to take a look at number 6 from lesson 6. So here it says Lucius takes 10 meters of rope and creates a triangle with these interior angles, and we want to determine the length of each side. So first of all, notice that if I'm only given the interior angles, we know that that's not enough information to determine to solve the triangle, to determine the lengths of the triangle. But they do give us this extra piece of information, so hopefully it will be enough. So let's start by drawing a triangle. So again, the angles are not the same, so let's try to make sure we don't draw it so that they look like they're the same. All right, so this looks to be the smallest angle, so I'll call this 30. This looks to be the one that's in the middle, so we'll call that 70. And this one here looks to be the biggest angle, so we'll call that 80. All right, now what we do know is that the total length, okay, the perimeter must be equal to 10, because that's what we're using to create the triangle. So since we're looking for the sides of the triangles, let's give them names. So let's say I call this side X and I call this side Y. Now I could call this side Z, but I actually don't need to, because I know if the total is 10 meters, then this remaining side just must be the total of 10 minus the lengths of the other two sides. Okay, and so what I've done is I've at least minimized the number of variables I have to work with. But there's no way to work with this question without at least these two variables. And this is where I hope at this point in the course, when we see a problem that involves two variables, we should know that we're going to be solving a system of equations at some point. All right. So since we're working with the side lengths and we know all the angles, it looks like we can use sine law here, okay? Because we have information about each of the opposite angles, regardless of what side length we're using. So let's start by applying, I would say, the easiest one. Let's use the two sides that are the simplest. Okay, so equation 1, I'll use side lengths x and y here. So I can write x over the sine of its opposite side. So x over sine 30 is going to be equal to y over the sine of its opposite angle, which is 80. All right. So now to create another triangle, well, I'm going to have to work with this side length here. So I'll use this one again, x over sine 30, x over sine 30, and that's equal to this side length, 10 minus x minus y, all over the sine of its opposite angle, which is 70. All right, so this is my system of equations, okay? Now, if I try to just subtract them, I could actually eliminate these sides here, because x over sine 30 minus x over sine 30 just becomes 0. The problem is I'm still going to be left with two variables in my remaining equation, okay? And that's what we don't want. We want to end up with just one variable. So what I'm going to do is use substitution. Okay, and I think the best thing to do is to isolate the y in this equation and then substitute it for the y in this equation here. Makes more sense to use x and y because then there's only one substitution, as opposed to isolating x. I would have to substitute it into two places. All right, so now this is where we have to make a decision. Do we use approximations for these signs, or do we try to find the answer exactly? And normally I try to encourage you to find the exact answer, but I think the algebra is just going to start getting too complicated. All right, so what we're going to do is we're going to stick with approximations and we'll get, still a reasonably good answer. So the first thing I'm going to do, so if I call this equation 1 and this equation 2, so from equation 1, I'm going to isolate y. So I just have to multiply sine 80 to the other side. So y is equal to sine 80 x over sine 30. And so, like I said, I'm going to use an approximation for these numbers here. So y is equal to, so let's get our trusty calculator here. So we've got sine of 80 divided by sine of 30. And that gives us, we'll keep two decimal places, so 1.97. So this is equal to 1.97x. And so now what I'm going to do is input this into equation 2. Okay, this is going to be my substitution. All right, again, I'm going to do some approximations here. So let's take 1 over sine 30. Let's see what that gives us. So 1 divided by sine of 30. Okay. Oh, actually gives us a nice number. Okay, so this just ends up being 2x equals 10 minus x minus. Now I'm going to substitute y with what I um, found earlier. So 1.97x all over sine 70. And you might be wondering, why didn't I calculate this? Well, because I'm going to have to multiply it to the other side. So when I'm solving a linear equation and I've got fractions, the easiest thing to do is to just clear the fractions. So here I'm going to multiply both sides by sine 70 to get rid of it on the right-hand side. Okay, so if I have here 2 times sine 70, so I've already got, oh, sorry, I already got I had the 2 there before, so 2 times sine of 70 is equal to 1.88. So we have 1.88x equals 10 minus x minus 1.97x. And so now I can just bring all the x's to the other side. Okay, so here I have the 1.88. I'll bring this minus x to the other side, so that's going to be plus 1. And then I'm going to bring this minus 1.97 to the other side, so it's going to be plus 1.97. So in total we have 4.85x equals 10. And the last step will just be to divide both sides by 4.85. So 10 divided by 4.85 is equal to 2.06. All right, and that gives us one of the side lengths of my triangle, this one here. So this is all in meters, so this is 2.06 meters. Now I can substitute that back into my initial equation. Y is equal to 1.97 times 2.06. All right, so let's do that. So 2.06 times 1.97. So that is 4.06. And that gives me the second side of my triangle. And then lastly, to find the last side, I'm going to do 10 minus x minus y. And that's equal to, so got 10 minus 2.06 minus 4.06, and that's equal to 3.88. And there's the three sides. Now let's see if this answer makes sense. So here x was the shortest side because it's opposite the smallest angle, and we see, yeah, it's the smallest of the three. This one here is the longest, and it makes sense because it's opposite to the largest angle. And this one here is in the middle. It makes sense because it's opposite to the middle angle. So our answer does seem to be reasonable. So let's do a quick recap. So step number 1 was to realize that we couldn't solve the problem just with the angles. Okay. So in order to solve the sides, we needed to give them names. So we used variables. But the important thing here was to realize that that third side could be written using the other two sides because you know the total was 10 meters. And anytime you have two variables, you have to be thinking of solving a system of equations. This case here, we use substitution, but in order to make it a little more manageable, we just approximated these sine values so the algebra wasn't too crazy. Okay, that is it for this one.